so here we go. Now we're doing chapter 3, okay? We're going to create numeric summaries. Numeric summaries and what we call statistics, okay? So sometimes we gather data, okay? So imagine a data set. Okay? And a data set consists of a bunch of rows and columns, right? The rows represent each case, and the columns represent each variable. Is that legible? Okay. So imagine having a data set. We've got rows and we've got columns. Each row is a case. Each column is a variable. Now let's say you wanted to summarize the data in one of those columns, okay? We want to summarize the data in one of those columns. Now we talked about already about a couple ways to summarize data, okay? And a few of them was with graphic summaries and with frequency tables, right? So we've already learned summaries with graphic displays and frequency tables. Okay. Well, we're going to, in chapter 3, we're going to introduce another way to summarize data, and these are single number summaries, okay? And in other words, these are known as statistics, okay? Statistics. So a statistic, this is slightly different from the subject of statistics, but this is just like the practice of medicine is different from a piece of medicine that you might take, okay? A statistic is different from the subject of statistics, okay? Statistics are single number summaries for our data sets. Okay? And we have summaries or numeric summaries to summarize or describe the shape, or not shape, the center and the spread and, you know, other aspects of our data, okay? Now, we deal with statistics all the time, okay? Except you might not even realize that, okay? So, if you watch sports, you're familiar with sports statistics, right? So if you watch baseball season just started, and you're talking about pitchers, you might talk about their ERA, their earned run average, or their WHIP, you know, walks, hits per innings pitched, things like that. And these are just different ways to summarize the performance of a pitcher, okay? Now, there's different pitchers and different players, and some are good at this and some are better at that, and others are like this. But in one way, if you just want to kind of compare two different pitchers without getting into, oh, this pitcher's really good at, you know, throwing a curveball, and this one has a really mean fastball, and all, you know, there's all sorts of things to describe a pitcher, but you can just use a single number to kind of gauge, you know, how does one pitcher compare to another. And you can say, well, this pitcher's number is this, and this pitcher's number is this. Therefore, overall, we might say this is the better pitcher, okay? Same with, you know, football. You've got passer rating for quarterbacks, and you can just say, you know, every performance is different, and every quarterback is different, but you can just kind of use a single number to summarize the performance of the player, okay? Same with movies, okay? You go to Rotten Tomatoes or some movie site and they give you a score. They say, this, Fast and Furious 7 scores like a 82 on Rotten Tomatoes or something. Let's just go to see what's at Rotten Tomatoes right now. Okay? And well, it's just all we're doing is we're just taking a bunch of people's opinions about a movie. Okay? This number 82%. Okay, for Furious 7, it tells us nothing about the movie, all right? We don't know, just seeing Furious 7, 82%, we would have no idea it's about cars flying out of airplanes, We wouldn't know that, but we say 82%, oh, it must be at least entertaining, okay? Is it going to win Oscars? Well, probably not, but, and then Get Hard, whatever that movie's about, 29%, so... maybe that was not the best example to pick, okay? And then Cinderella, 84%, okay? But we just look at these things and we say, oh, well, this movie is great, or this movie is terrible, or I want to see this. And these single numbers, which really don't really tell us a whole lot about it, except just this one number, we use and we say, oh, well, this probably means this. And that's all we're doing with statistics, okay? You just imagine a data set, and if we can gather all of this information about the students in our classroom, okay, and we can just boil it down to a single number, okay? And if you looked at, my past classes and things like that, you're not going to know the nuances and details of people's personal lives and things like that just from this single number. But maybe we can summarize this class with a single number and summarize another class with another number, and we can kind of make comparisons that way, okay? And that's the purpose of using statistics, is we're just boiling down an entire set of something into just the single number, and we can use these numbers to make comparisons between the whole groups, okay? If we wanted to try to compare, and this is one thing I don't like about capitalist America. I love America and I love everything about it, but there is something about our society that I feel maybe dehumanizes people, okay? So a lot of times when you meet someone, within the first few minutes of conversation, it goes, what do you do? Okay, and we're essentially sizing up the other person, and if the person says, well, I'm a barista at Starbucks, you automatically start making judgments about this person, okay? Someone says, oh, I'm the CEO of a company, you start making judgments about this person. And essentially, one thing that we're doing is we're imagining what this person's salary is, and we're basically judging, well, not always, but we might be judging this person's life and choices of their life because, one person's salary is this high and another person's salary is only this and things like that. But essentially, we're just taking one little aspect of someone's life and we're creating judgments or things like that. But anyway, that's one way. We could, if we wanted to, compare people by just taking their salaries and saying, well, this person is at least important in some regard for this and that, but things like that. So anyway, that's all I'm saying. We're going to learn a bunch of statistics in the next hour or so. You're going to learn, the mean and the median. I'm going to list all of these off, and I don't want you to get lost in the definitions and the calculations. These are important. You've got to learn the calculations. You've got to know the definitions. You've got to know all of these things. But the main purpose of the statistic is it's a single number to summarize our data set, and it's most useful in making comparisons between data sets. Okay, so statistics as numeric summaries are most useful to make quick comparisons between data sets. Okay. You can boil a data set down to a single statistic, and using those values, or as numeric summaries, we can make quick comparisons. And so today we're going to learn two, I guess, classes of statistics. Okay, so we're going to learn statistics to summarize center, and statistics to summarize spread. Okay, to summarize center, we have the mean and the median. And to summarize spread, we have the range, the interquartile range, which is abbreviated IQR, and we have the standard deviation. Okay, and again, these are just ways to boil down a set of data into a single number. Okay, these are all, quote, boil down to a single number that we can use to compare a certain aspect. All right. Is that good? Everyone's got that written down? No. Okay. No problem.
Yeah.
How about now?
No.
Okay. Well, I'm gonna go anyway. Here I go. There we go. Oh no. Okay, fine. You guys are killing me. Okay, now we go. All right, so let's talk about measuring the center. Now, I want to make a distinction in our book. Okay, so in the book, they say summaries for symmetric distributions versus non-symmetric distributions or skewed distributions and things like that. Okay, so let me just address something that the book does. Summaries for symmetric versus skewed distributions. Okay. Oh, by the way, distributions is another word for a set of data. Okay. It's technically not the same, but for our purposes, we can treat them the same. Okay. Skewed data sets. Okay, so the book kind of gives this impression that certain measures are better for some, maybe only exist for symmetric versus skewed distributions, and that's not the case. Okay, so with symmetric distributions, the book talks about the mean and the standard deviation. And these are useful, are I guess intended or more useful for the symmetric distributions. And for skewed distributions, we have the median, range, and IQR. Okay, but the truth is the mean and the standard deviation exists for skewed distribution, and these exist for symmetric distributions. Okay, so all numeric summaries exist for all sets of numeric data. Okay, all numeric summaries. All right, that I will do my best. Let's see. Let me pull up my. Where is the
doesn't look terrible. It's just
brush palette? Here, let me.
The W between symmetric and skewed, is it for width?
Huh?
The W between
Summaries with skewed distribution.
Oh, versus. I'm sorry. Let's see.
Oh.
See, you guys. Symmetric versus. Okay, and I made my pen a little bit thinner, but I don't know if it's too thin now. Okay. So let's see, in the book, summaries for symmetric versus skewed distributions. Okay, so all numeric summaries, is this still legible? Is this? No.
That's worse.
That's worse. You guys make my life so hard.
you can just increase your font size.
Oh, just make it bigger? All right, that's what they want. All right. Let's try this. It's okay. I'm trying my best. All right. All numeric summaries exist for all numeric data sets or numeric distributions or data sets. Okay? But some are more useful for certain data sets, depending on the shape of the data. Okay, and so that's all this book is going for. Okay, for symmetric data, the mean and standard deviation are more useful. For skewed distributions, the median, range, and IQR might be considered more useful. Okay. In the same way that I don't know. It can be, you know, like a teddy bear is more useful for young children, but grown-ups can appreciate a teddy bear as well. So it can be. We can still have the mean and standard deviation. It's not a bad thing. It still tells us information. Okay. All right. So let's talk about the mean. Okay. This is one sense of the word average. Okay. So when you hear the word average, generally refers to the mean. And I think you guys all learned how to find the mean. You add up the numbers. So you calculate. Yeah. To calculate, add up all of your numbers. And divide by how many you have. Okay. The symbol for mean of a sample of data. So we're talking about samples of data. The symbol for the mean is X bar. Okay, the formula is x bar is equal to the sum of all of our x's divided by n. Okay, so just an aside, this means sum or add up. Okay, and n is how many numbers you have or your sample size. N is sample size, how many numbers you have, and x is each data point. Okay, so this formula basically just says exactly the same thing. Add up all the numbers, divide by how many you have. So if our data set is 1, 2, 3, 7, x bar would be 1 plus 2 plus 3 plus 7 divided by 4, right? So I have 13 divided by 4, and I get an average of 3.25. Is that okay? Good. Now the mean, let me just move this up. Visual representation of the mean, okay? The mean is the balancing point of our data. Okay. So here I'm going to draw a number line. And I'm going to draw our data points. Okay, so I'm going to make a dot plot here. Got a dot at 1, a dot at 2, a dot at 3, and a dot at 7. Okay, so imagine that this is a seesaw, or it's a plank, and each of these red dots are stones or bricks. Where would I want to put the little, the fulcrum so everything stays in balance? Okay. Well, the mean says I should put it at 3.25. So I want to put my little green triangle fulcrum right here. And this says it will stay balanced here. Okay. So even though there's 3 rocks over here and only 1 rock over here, because this one is so far away, it balances out the 3 stones here. Right? You guys are familiar with seesaws and how that works, right? When they're close to the fulcrum, it doesn't have as much leverage. When they're far away, it's got more leverage. So even though there's only 1 all the way out here, because it's so far, it balances out the 3 other stones. Okay? So the mean, the visual representation is that it's the balancing point of our data. Okay? And this, this was a simple example of just 4 data points. But if we had 50 data points, it's the same idea. If you drew a bunch of stones, all 50 of them, and you needed a balancing point, it would be right at the mean. Okay, I'm going to go on. So the other measure of center is the median. Okay, the median is the halfway point. Okay, this is the spot or the value where half of the data is smaller. Yep, smaller than this value. And likewise, so if half are smaller, then that means half are larger. Okay, or if you're thinking of for a histogram or curve, it is where you would use half the paint of painting the whole surface, okay? You know, the vertical line where you would use only half the paint. Okay, so let's just take our same data. We have 1, 2, 3, and 7. Okay, how many data points do I have? N is equal to 4. I've got 4 data points. So half of 4 is 2. So I want the spot where 2 points are smaller and 2 points are larger. So the median goes right there. Okay, 2 values, okay, 2 data points are smaller. Two data points are larger. Okay, so I drew this dotted line between the values 2 and 3. So where is the median? Halfway between 2 and 3. 2.5, okay? So the median is halfway between 2 and 3. Median equals 2.5. So another way to calculate the median, and you don't have to do this, okay? Well, one key is whenever you're finding the median, absolute number one important thing is to put your data in order from smallest to greatest, okay? So very important. Always arrange your data from least to greatest. We have a question.
Yeah, what if the data has 5 numbers instead of you take the middle?
Okay, then you take the middle number, and we can do that, all right? Okay, so very important, arrange your data from least to greatest, okay, and then finding the median is find the spot where half is bigger and half is smaller, okay? Where half is greater and half is smaller. Okay, this is one method is the median is the value in the n plus 1 over 2th position. Okay, the median is not n plus 1 over 2, but it's the value in the n plus 1 over 2th position. Okay, so for example, if we go back to this data, we've already figured out, well, this is this is not the best example. We'll just start another set of data here. Okay, so let's say I've got 10 data points, or a bunch of data points, and I've already arranged them from least to greatest. Okay, so let's say these are scores on a test, and we've got, you know, somebody scored a 60, someone scored a 68, and then we have a 70, a 72, a 77, an 80, an 83, 85, 1, 2, 3, 4, 5, 6, 7, 8, 89, 96, 100. Okay, so let's say this is one set of data. Okay, how many data points do I have?
11.
Okay, I've got 11. All right, so What is half of 11?
5.5.
5.5, okay? So basically I want 5 smaller, 5 bigger, and then one is going to be split in half here, okay? So in this case, my median is going to be right here, okay? This is my median. Median is 80. Now if I could do this n plus 1 over 2th position, what's n plus 1 over 2? 12 divided by 2, so n plus 1 over 2 is equal to 6. So if I count, I can go 1, 2, 3, 4, 5, 6. This is in the 6th position, so my median is also the 6th number, 80. Is that okay with everyone? Finding the median that way? All right, let's say I just tack on one more number, so I have 12 numbers. Okay, so another data set. And we're going to stick on one more number here. Somebody scored a 42. Okay. What is the median of this data? So now I have n is equal to 12 data points. So I want the spot where half are bigger and half are smaller. Where's my median? Between 77 and 80. Is that clear? So my median is right here. Between 77 and 80?
Yeah.
Okay, so what is the value of my median? It's halfway between 77 and 80. Yeah, so I would, if I can't do that in my head, then I would do 77 plus 80 divided by 2 is equal to 78.5. So my median for this thing is 78.5.
Can you also just subtract the two numbers and then divide that number that you added to the first number before?
What? Oh, okay. Like do 80 minus 77 to get 3, and then divide 3.5, and then add that to 77?
Yeah.
Yes, that is actually doing the exact same thing as doing 77 plus 80 divided by 2. It's just done in a different order. So that is exactly the same thing. Okay, finding the median is okay with everyone. Okay. Again, these are just summary statistics to compare center, okay? And so when we're talking about center, we're just getting an idea of kind of what typical values of the data are, okay? Not necessarily what the most common value is or whatever. It's just center gives us an idea of where the center is, okay? So you can imagine, a group of college students at different universities, okay? And we can ask, what is the average number of alcoholic beverages you had this past week, okay? And if you go to one school, the answer might be 0 or like 0.1, okay? So if we went to like Brigham Young University and we said, what was the, how many alcoholic beverages did you have in the past week? And the average across a bunch of students that we ask might be like 0.1, okay? If we go to like Pennsylvania State and we ask, how many alcoholic beverages, the average might be like 11, okay? Now, that number is just a single summary. Every student at Pennsylvania State is different. That 11 might come from students who had 0 drinks in the last week versus, some students who might have had 20 drinks in the past week, okay? So you're going to have a wide range of numbers there, but you can kind of boil it down to a single number. And we can say, oh, okay, well, Pennsylvania State maybe has drinks more on average than, this other school, okay? Brigham Young, where, I don't know what the rules are, but I imagine there's not a whole lot of drinking on campus there, okay? So, again, these measures of center just kind of give you an idea of what the typical values are, not necessarily what any one individual value is, okay? Or another example, you know, if we ask, you know, how many children are there per household in the United States, that answer is something like 2.3, okay? In the United States, the average number of children per household is something around 2.3. That gives us an idea of the number of kids in the US. If we go to Japan, it's going to be like 1.1, okay, or 1.4. They're suffering, you know, not a whole lot of children. You know, other parts of Europe, you know, you got numbers around 1.8 or 2.1. To maintain a sustaining population, you need at least 2. You go to Ireland, it's like 3.9, okay? And so you get an idea of certain things. Of course, any one family is not going to be 3.9. It's going to be 3, or it's going to be 4, it's going to be some whole number. But these summary statistics give us an idea and allow us to kind of compare this one aspect from country to country or school to school or whatever we're talking about. Okay? Is that all right? I didn't write anything up there. Do I need to write that up there? Okay, so just keep in mind, and we got two values. We've got the mean and the median. They both serve the same purpose. Let me just talk about a few differences between the mean and the median, okay? Okay, so the mean, again, is our balancing point. The median is the halfway point. Okay, the median is not affected by skew. Not affected by skew, not affected by outliers. Okay, and skew and outliers go hand in hand. Meanwhile, the mean is affected by skew and outliers. Okay, so if you have a distribution that looks like this, okay, so this would be what? We would call this shaped skew right. That's right. Okay, so the median, if we're thinking of, you know, where is half the paint used, I'm just eyeballing this and I don't know. So I'm just going to say this is the median, okay? The median might be here, and the mean gets pulled in the direction of the skew, and the mean is over here. If this wants to be balanced, maybe we've got to put it over here, okay? So with skew, the skew or the mean gets quote unquote pulled in the direction of the skew. And so this is why the book says the median is preferred for skewed data and the mean is preferred for symmetric data. Okay? So we might say median. I don't know why I'm writing it up there. So we'll say preferred for skewed data. Okay? But the median and the mean exist for both skewed and symmetric data. Is that okay? Can I go on to the next slide? Thank you. All right, so let's talk about summaries for spread. Okay. So spread is another notion for a set of data, okay? Spread is the concept of, are all of our data points similar to one another or are they vastly different, okay? are our data points similar to one another, which indicates low spread, or are they quite different? Okay, which would indicate high spread. Okay, so here's not a great example, but an aspect, if we were to go around the classroom and we asked, how many fingers do you have on your left hand, we would get a bunch of values that would have very low spread. Okay, so if we said how many, this is a numeric variable, right? How many fingers on your left hand? Now I don't know if anybody is missing any fingers or anything, but by and large, okay, nearly all respondents, okay, nearly all, not probably, maybe not everyone, but nearly all will report 5. Okay, and so when you look at your data, there's not going to be much difference between the different people, and so this would be a case where we have low spread. Okay, nearly all of our data points are the same. Okay. On the other hand, we could ask something like, I don't know, how much money is in your bank account? Okay, and we will probably see a wide variety of answers. Okay, how much money in bank account? Okay, and so we might see answers anywhere from 0 to, you know, thousands of dollars. Okay. All right, I don't know. I don't know how much money you guys have. It doesn't matter. Okay, but we're gonna see a large amount of spread here. Okay. Large spread. What's that?
No, I was making a joke. The left skewed. What do you think?
Yeah. Well, actually, probably right skewed, because I imagine for bank account, most people will have between 0 and like a few thousand, but then there might be a few people who are like rolling in the cash, right? So most people will be down over here, you know, 0 to, I imagine 0 to, I don't know, $5,000 or something. But you know, maybe you know, could somebody here have, you know, 25 grand in the bank account? Sure. Okay. No. You don't have to do that. Okay. We're not gonna. Okay. So anyway, you know, how much money in the bank account? We're gonna see a large, you know, a whole bunch of different answers there, right? Some are you gonna say $5, and some of you will say, you know, I don't even have a bank account, right? I just live with whatever's in my pocket, and you think, you know, so how many fingers on your left hand? We're probably not going to see a whole lot of spread in terms of our numbers. Okay, we might see someone with less than 5, but we probably won't see very many people with over 5 fingers. And you know, so our histogram, if we make one, will, you know, if we have 0, 1, 2, 3, 4, and 5. We'll just have, you know, 1 bar right here for almost everyone, and then yeah, maybe we have someone with 4 fingers, or maybe we have someone with 2 fingers. I don't know. You know, I'm not sure. Okay. So not a whole lot of spread. Okay. So this is just the concept. Does this concept of spread make sense? Okay. So what do you think has more spread? Differences in gas prices for a gallon of gas right now, or differences in I don't know, This is a terrible example now. Okay, yeah, differences in gas prices versus differences in a pack of cigarette price. Yeah, maybe that's. We'll just say within Los Angeles.
What has a larger spread?
Yeah, which one has more spread?
Gas price.
Cigarettes.
Cigarettes, don't they have like different
Yeah. Okay. So this is all right. This is a tough question. I don't know the answer, but I would guess cigarettes probably have more spread. Okay, because we pay very, very close attention to the amount of spread in gas prices. You know, like 10 cents for a gallon of gas feels like a huge thing, but that's like if gas is $3 a gallon right now, 10 cents is like 3%, a 3% change. Okay, packs of cigarettes, depending on I guess the brand and things like that. There's probably I think a range of a few dollars in price from pack to pack. Okay, I don't smoke, so I'm not super familiar. But when you go to the gas station, you see the prices posted, right? So I imagine there's a few dollars of range for cigarette prices. But when you go to gas stations, you would be very shocked to see a difference in dollars from one station to another. Okay, and so because of that, I would say cigarette prices have a larger spread than gas prices. Okay, question.
A larger spread indicates variation.
Yeah, and larger spread indicates more variation in terms of the numbers that we see. Exactly. Yeah. So actually, variation, the term variation, there's a technical term, is one measure of spread. Okay, it's actually the standard deviation squared. Okay, so we're going to go over the definitions in terms of different measures of spread, but I don't want us to get lost in those things. I want us to remember overall the concept of spread first. Okay, and once we have that, the values that we use in the range, the IQR, the interquartile range, and the standard deviation these are all just ways to quantify spread. We're just giving this spread a value. So we can say this one has 10 spread and this one has 20 spread, okay? That one, and so we say stuff like that, okay? Rather than just saying more spread and less spread, we can give these things numbers. Okay, so let's go into, we'll start with the easy one, okay? The range, all we're doing is the largest point, the maximum, minus the minimum. That is the range. So if your data is 1, 2, 3, 7, your range is what? 6, okay? That is your range. Simple enough. Any questions there? Okay. And so if we looked at, let's say these are the ages of kids in one family. This is the, I don't know, the Adams family, okay? And then we've got the Baker family, okay? Let's say the kids' ages, the data is 2, 10, 12, and 18. Okay, so the range here is what? 16. Okay, and so we would say this family has less spread and the Baker family has more spread, right?
Professor?
Yes.
Can you remind me how you got both numbers for the ranges?
Maximum minus minimum, okay? So the largest data point minus the smallest data point. 7 minus 1 is 6. 18 minus 2 is 16. Okay? That's the range. Okay, so then we have the IQR, which is the interquartile range. So here I've got to talk about what a quartile is. Okay? there are technically 4 quartiles, but we really only deal with 2 of them, okay? Q1 is the point where 1/4 of the data is smaller. Q2 is the point where 2/4 of the data is smaller.
Smaller than what?
Smaller than this point. Okay? So if you think of the definition of the median is the halfway point, right? It's the point where half of the data is smaller than the median, and that means half are larger. Okay? Q1 is a point where 1/4 of the data is smaller, and that means what? 3/4 is larger. Q3 is the point where 3/4 is smaller, and Q4 is where 4/4 is smaller. Is that okay? Okay. So Q2 is equivalent to what? The median, okay? So Q2 is the median because 2/4 or 2/4 is the same thing as half. So when we say 2/4 of the data is smaller, that's the same thing as saying half the data is smaller, and that's the definition of the median. What would Q4 be? This is the maximum. Okay? 4/4 or all the data is smaller than the maximum. So Q4 is the maximum. So when we talk about quartiles, we're really only talking about Q1 and Q3, okay? Because Q2 we call the median, and Q4 we call the maximum. Is that okay? Yes.
Maximum as in 7 for the Adams family?
Yes. Maximum as in the largest data point in your set of data. Is this okay?
Yes.
All right, so the interquartile range is defined as Q3 minus Q1. It's the difference between Q3, the spot where 3/4 of the data is smaller, and Q1, the spot where 1/4 of the data is smaller. So that is the IQR. How much of the data is in between Q1 and Q3? Now, how much?
3/4.
Between Q1 and Q3?
2/4.
2/4, right? So just imagine your fuel gauge, right? On the gas tank, okay? And it's got marks like this, right? Full and empty, and it says, 1/2, 3/4, and 1/4, okay? So how much is in between 1/4 and 3/4? How much of your gas tank is in between those two? Half of your gas tank, right? Okay. If your needle is right here, how much gas have you spent? 1/4 of your tank, right? Okay. So it's the same kind of idea here. This is Q1, this is Q2, which we call the median, and this is Q3. Okay. So we're just asking, what's the difference between Q3 and Q1? That's the IQR. So how do we calculate? So to calculate the IQR, we have to know how to calculate Q3 and Q1. Okay. So to do this, we first find the median. And then the median splits your list into 2 halves, right? The median is the halfway point. So split your list in half at the median. And to find for Q1, find the, quote, median of the lower half. And for Q3, find the median of the upper half. So I'm just going to scroll back really quick to just grab a few numbers from right here. Let's just, I'm going to just borrow these numbers or just...
They wanted us to remind you to take attendance.
Oh, okay. Let's do that. Thank you. Thank you for reminding me. Okay, so we're going to use this to find Q1 and Q3. Okay, these were test scores. All right, so if you have your attendance sheet, pass those forward, and if you forgot those, just let me know. Or I don't know. Okay, what's your name?
My name is on it.
Okay, so I'm going to take that.
Do I have to fill out any?
Okay, so actually, yeah, just pass them. I would say pass them down to your left, and I'll just walk down the aisle and grab these. Okay. Okay. You know your number? Okay. Here. Okay, write your name down there. Okay, just write your name down right there. Yeah, yeah. So I'm going to return these. 1, 2, 3, 4, 5, 6, 7. Okay. Okay. So I got, hang on, I'm counting in my head here, so. Just write your name down right here. Okay. Let me just. Okay. All right. Thank you. Yeah, I just do a quick count of how many papers I got and how many heads I counted here, just to make sure no one's trying to cheat. Okay. So anyway, let's go ahead and find Q1 and Q3. There was a step that I skipped or I've already done here, and what is the first very most important step of finding a median? Step 1 is put the numbers in order from least to greatest, right? Always put numbers in order. Okay? And then, so for finding Q3 and Q1, we first find the median. Okay? So we've already found the median, and we said that was 78.5. That's okay with everyone? Okay, so I've got a line, and I split my list into 2. So now I've got 6 numbers on the lower half, 6 numbers in the upper half. Okay, so what is Q1? It's going to be the median of these 6 numbers. So where is Q1? 69. Okay, so Q1 goes right here, is equal to 69. Is that okay with everyone?
Yeah.
Okay, and where's Q3? Halfway between 85 and 89. So if we're not sure, we would do 85 plus 89 divided by 2. You punch that in and you get 87. Okay? So Q3 is 87. Is that okay with everyone?
Yes.
Okay, great. So our IQR is Q3 minus Q1, 87 minus 69, and that gives us an IQR of 18. Okay. Now again, the value in any of these statistics is that we can use them to compare from distribution to distribution. So if we have different sets of data and another set of data, so if I gave another test, so let's say these were test scores for one class and we have an IQR of 18. Let's say I had another test for a different class and I said the IQR is 4. What does that indicate? So in this class, for these 12 students, the IQR is 18. If I said I took or let's say we did another class where there was 12 students and the IQR there was only 4, what would that indicate? So it's not a matter of how well or how poorly they did, okay? Because that would be a measure of center. That would be a measure of the average score. Either the median or the mean would give us an idea of how well they performed. But if it's not about sample size, because I said both classes have have 12 students. But let's say another class with n equal to 12 students has an IQR equal to 4. Over here our IQR is 18, right? So what does this mean? IQR of 4 means the spread in the scores is much smaller. So here we see, a good amount of range. We've got scores, scores down here from, 68, 70, scores up here 85, 89, okay? If the IQR is only 4, then that means a lot of the students had very similar scores. So we would have scores where maybe we don't know what those numbers are, but if one score was 80, then probably a bunch of students scored 80, 81, 82, 83, 84, 81, a whole bunch of scores in the 80s. So meaning lots of students had very similar scores. To have an IQR that's much smaller means many students have similar scores, okay? IQR 4 means we've got low spread. And so you just have to think what it means to have less spread. IQR over here, 18, we've got more spread. So there's, kind of a more variety of scores. If the IQR is only 4, then that means less variety in the scores. The scores are much more similar. Does that make sense? Okay, so it's important that we remember what all of this stuff means when we're talking about spread. IQR and range, these are just ways to quantify that concept of spread. Yes, question?
Like where you're talking about the IQR for number 4,
Uh-huh.
could that be like, it could be in either the high range?
Yeah,
or
it could be
low
high or
range?
it could be low,
Never
okay?
be-
The IQR does not indicate whether the scores were high or whether the scores were low. It's just an indication of spread. So it doesn't tell you the whole picture. It just tells you, okay, a lot of the scores were very similar. Okay. So maybe that might be an indication that the test was too easy and everybody scored really high. Or maybe the test was too hard and everybody did really poorly and that's why everybody's scores were similar. We don't know the full story. We just know this one little aspect that the scores are quite similar. All right, so in this last bit, I need to talk about the standard deviation, and I'm also running out of time to talk about box plots, but let's talk about the standard deviation. Okay, standard deviation, this is the one where maybe students struggle the most just because the steps in finding the standard deviation are complicated, but again, the concept is just like the IQR, just like the range. It's a measure of spread. So don't forget that we're just talking about a measure of spread. Okay. Okay, so to calculate the standard deviation, or a loose definition of the standard deviation, SD, or abbreviated just S, is that it can be thought of as the average distance from the mean, but it's not really, okay? So just imagine a set of data. We got 1, 2, 3, and 7, okay? We found the mean. What is the mean of this data, of these 4 data points? 3.25, okay? The mean is 3.25. So if I ask, what is the distance from the mean? So how far is the data point 1 distance, how far is it from 3.25? Yeah, it's 2.25 away, okay? And how far is 2 away? And let me space these out here. Yeah, I got to kind of move this over here. Just spacing these out. Okay, so 2 is what? 1.25 units away from 3. How far is 3 away from 3.25? 0.25, and how far is 7 away from 3.25? 3.75, okay? Let me just, is that okay, this concept of distance from the mean? Let me just write this a little bit clearer. So we have distance from 3.25. Is that okay? So the standard deviation is kind of like the average of these numbers, but it's not exactly that, okay? And it's actually going to be, we're going to square everything, and then we add them up, we divide by n minus 1, and then we take the square root. Okay, so let me just write the steps here, okay? Steps to find standard deviation. Okay, so 1, find the mean. 2, find the deviations or distances from the mean. 3, square those values, add them up is number 4.
What does that say? Deviation?
Deviations, or basically a distance from the mean, okay? You know, when you talk about someone deviating from the path, you're saying they're going away from the path. So here we're talking about, you know, how far are these deviating, or how far are they going away from the mean? So find the deviations from the mean, square those values, add them up, divide by n minus 1, okay? So steps 4 and 5 combined is kind of like finding the average, but instead of dividing by n, you're dividing by n minus 1. So it's a little bit weird. And then the last thing is take the square root. Okay? So what have we already done? We've already found the mean, and we've already found the deviations from the mean. So I'm going to do step 3, which is square these values. So we're going to do 2.25 squared. Let me just pull up my calculator. Okay, 2.25 squared is, of course it would do that. We want that, oops, shoot. What are you doing? Okay, so we want 2.25 squared. And that gives me 5.0625. We have a question.
7, why isn't that negative 3.75?
Okay, so technically these should be the negative ones, and this one should be positive, okay? But it doesn't matter because we're squaring everything, okay? We're going to square everything, so it doesn't really matter. I think in the homework video I put the negatives there, okay? And then I'm going to square 1.25, and I'm going to write 1.5625, and I square 0.25, and I get, what is it, 0.0625? Yeah, 0.0625. I'm writing them on different levels because they're running into each other. And I square 3.75, and I get 14.0625. Is that okay? All I did was I take each of these values and I squared them. Is that okay with everyone? And then now I'm going to add all of these up. So I'm going to add up all 4 of those numbers, plus 0.0625, plus 1.5625, plus 5.0625, okay? So if I add up all 4 numbers, add these 4 numbers up, and I get 20.75. Now I'm going to divide by n minus 1. So what is n? How many numbers do I have? 4. What's n minus 1? 3. Okay, so I'm going to divide by 3. So 20.75 divided by 3 is equal to 6.9167. And the last thing is take the square root. So I'm going to hit square root of the answer, and I get 2.62995. So I'm going to just write 2.63.
What do you divide by 3?
Because I'm dividing by n minus 1. Okay? Here, I'll draw little arrows. So that's this step. That's this step. That's there. And there.
Will you upload all of your notes?
Yes, I did that last week, and I intend to do that this week as well. Okay? All right, so this is how we find the standard deviation. Is that okay? Okay? I think I've got a supplemental video on the internet about the standard deviation. Okay, and I know we got 5 minutes left, so there's just one more important thing. And I have to introduce the concept of a z-score, okay? So again, the standard deviation is just a measure of spread. We have all of these complicated steps to get this number, but again, if we took another set, let's say these were the ages in the what we said, the ages in the Adams family, right? Okay, and then so we have the Adams family, and the ages were 1, 2, 3, 7, and when we did the math, we got the standard deviation of 2.63. Okay, Baker family, what would the standard deviation be? Would it be more than 2.63 or less than 2.63? What do you guys think? More, right? Because the spread in ages for the Baker family is more than the spread in the ages for the Adams family, okay? And so the standard deviation will reflect that. So over here we had a standard deviation of like 2.63. Over here I would guess the standard deviation is going to be like 4.5. I have no idea, okay? I'm just making that number up. But if we went through the process, we would get a larger value for the standard deviation here because the ages are spread out over here, whereas here they're less spread out. Okay? And so don't lose sight of that when you're going through the process of finding the standard deviation. Okay. One last thing with the standard deviation, okay, is we have something called a z-score. Okay? A z-score basically turns the standard deviation into a unit of measure, okay? Okay, So I can look at that door over there, and I can say that door is, I'm just making up a number. Let's say I say it's 180 inches away. Okay? If it's 180 inches away, how many feet away is that? What would you do? You would do 180 divided by 12, and you would say
15.
it's 15 feet away. Okay, right? You do 180. There's that 12 inches in a foot. We would do 180 divided by 12, and we'd say, okay, that door is 15 feet away from me. Okay? With the standard deviation, we can do the same type of thing. Okay? So let's just go back to the Addams family children. Okay? And we said the kids were 1, 2, 3, and 7 years old. Okay? And we said the mean was equal to 3.25. Okay, so let's look at the oldest child here, okay? Wednesday Addams here. So how far is 7 away from the mean of 3.25? Okay, it's 3.75 units away. Okay, so 7 is 3.75 years, okay, away from 3.25, okay? But what we don't want is, we don't want 3.75 years. We want to know how many standard deviations away, okay? And so we calculated each standard deviation is equal to 2.63, okay? So how far is 7 away from 3.25 in standard deviations? What would I do there? Yeah, I would do 3.75 divided by 2.63, okay? So this is equal 3.75 divided by 2.63, and I get 1.426, okay? So this basically says 7 is 1.426 standard deviations away from the mean. Okay, so all we're doing is we're taking the distance from the mean and we're changing the units into standard deviations. Okay, so a z-score is the distance from the mean measured in standard deviations. Does that make sense? Okay, so to get this z-score, one way to do it is you take your data point and you subtract the mean, x bar. Okay, this gives you the distance from the mean, and you divide by how big your standard deviation is. Okay, so x minus x bar, this is distance from the mean. And then when we divide that distance by s, we get how many standard deviations we are from the mean. Okay, I know we're rushing through this topic. Okay, but the z-score just tells us how far we are from the mean in standard deviations. So we're not interested in like inches or feet or years. We're interested in how many standard deviations we are from the mean. Okay, and with z-scores we can then make comparisons between apples and oranges, and we can say this thing is 5 standard deviations away from the mean. This thing is only 2 standard deviations away from the mean. Therefore, the thing that's 5 standard deviations away from the mean is more unusual than the thing that's only 2 standard deviations away from the mean. Okay? You have some practice in your homework going over this. I will try to write up another sample quiz and get that posted so you can do your practice, and we'll see you guys next week. And enjoy. Okay.